Hopefully you're not waiting too long for a sunny day. Welcome to another science lesson. We're talking about that awesome big orange circle in the sky, the sun. However, speaking of important things, a famous Emerson giving us quote of the day. Great way to lead your life. And speaking of life, obviously, we need to understand the importance of the sun. So let's get right to it, folks. Let me give you a little bit of perspective. Right off the bat, show you this picture of our solar system. What's the first thing you see? What's your impression of the importance, or at least what's the most important part of our solar system? Well, for me, my eye goes directly to the middle. Obviously, the sun is so very important. We recognize that. Everything revolves around it. Why? Well, gravitationally speaking, it holds so much of the solar system's mass. In fact, 99% of it. Think about that for a second. It's incredible to think. All of the mass of Jupiter and Earth and everything else, all the other planets and stars, all that mass makes up only 1% of our solar system. Everything else is found in the sun. Incredible to think about. A couple other things to think about in terms of the sun. Some interesting facts I've come across. The sun, its size, we think is so very large. Yes, it certainly is. However, in terms of all other stars, kind of in the middle tier, it's known as a yellow dwarf star. Obviously not as large as the red supergiants or the blue and red giants, but pretty large in of itself, but not the largest that are out there. Speaking of the sun's size, its volume, speaking of the entire volume, we would need about 1 million Earths all squeezed together to fill up the entire volume of the sun. Now, we're not talking about how many Earths fit across the diameter. We're talking about how many we would need to fill up the entire volume of the sun. 1 million, or at least over 1 million, believe it or not. A couple other things. The Mother Nature creates things with many different sizes and shapes. In terms of a perfect sphere, the most closest is in fact the sun. What I mean by that is we look at its distance from pole to pole, pretty much equal to its distance from its equator going across, making it almost, not perfectly, but very close to a perfect sphere. We on Earth are not a perfect sphere. We're a little bit longer going from pole to pole than the equator. Now, a couple other things that we know. Speed of light travels at 300,000 kilometers per second. We know the distance from the sun to the Earth is about 150 million kilometers. What does that tell us? Well, a little speck of light that leaves the sun is going to take it 500 seconds, a little more than 8 minutes, to travel from the sun to the Earth. So we got to wait a little bit, not too long. A couple other general facts about the sun. The sun spins faster at its equator than the poles, much differently than Earth, where we travel faster at the poles in terms of spinning. This obviously deals with its shape again, being almost a perfect sphere. Another interesting thing, the sun rotates in an opposite direction than the Earth. Well, let me rephrase it. The Earth spins in an opposite direction from most other things in the solar system. We on Earth travel or rotate west to east. The sun, along with the moon, goes east to west. So kind of interesting. We're that lone wolf out in the solar system, we on Earth. Anyway, the sun has reached its midlife, has many, many billions of years still to churn out energy. Speaking of that, though, when it does start to die off, what we expect is that it will expand into a red giant. Now, What does that mean? The size of a red giant will eventually engulf Earth. So the distance from the sun to the Earth will change as it grows larger. It will obviously take over the Earth. However, when it ultimately dies off, it will contract into a very small white dwarf. Fascinating to think about. Don't worry, we won't be around for it. So, not to scare everybody off, but let's talk about what we really want to know about the sun. So, right off the bat, question for you. Is it a solid, liquid, gas, or is it a mix of these three states of matter? Well, let me stop the suspense. It's just simply a glowing circle of gas. So we recognize that. There's a couple parts of the sun. There's two main parts. Let's recognize the interior, and it has an atmosphere. When we talk about the atmosphere, it's going to be a little bit different than ours. Believe it or not, there's three parts to its atmosphere. But let's head back inside. What are the elements that are found in the sun? Let me give you a number. There's only two elements. If that's the case, what two elements do you think make up the sun? Give you a couple moments to think about that. What elements do you think are very important that would be found in the sun? Well, here they are. It's hydrogen and helium. What do we know about helium? Obviously, we use helium to fill up balloons. Hydrogen, obviously, we recognize a major component in terms of, obviously, water. Here's my question. If we were to compare these two elements based on what we know, which scenario do you feel is more likely to be correct? In other words, making up the sun, helium will make up about 75%, hydrogen 25%. Or would it be just the opposite? Hydrogen being 75%, helium 25%. Or would they be about the same amount? It's a question I'm going to ask you. Think about that. We'll get to that question soon enough. However, we look at this picture. I'm showing you three parts of the sun's interior: the convection zone, the core, and the radiation zone. I'm giving you three arrows. Which one do you think would make up which part? I'm going to ask you to try and think about how you would identify these three parts. Now, a couple other things that I want you to understand. Inside the core, one thing that you have to understand is it creates energy. Well, the sun's energy is created by something called nuclear fusion. Think about fusing something together. Fusing two things to get together creates energy. So we recognize hydrogen and helium is in the core. So here's a picture of this reaction. In other words, we have two things that come together. They fuse together to make something totally different. But they also create or give off, based on this reaction, they give off energy, which in turn is heat. So what I want you to understand here, folks, is we're going to try and move these different components. I give you two hydrogens, two heliums, and the word energy. Where would they belong in this picture? Well, let me give you a little bit of help here. Let me go back to this. Energy is what's being created. So we know energy is being created. I want you to think which one will fit into the two blues, which one will be the green out of these choices. Where will helium, where will hydrogen fit in? I'm going to ask you to get your thoughts on that. But let's talk about the atmosphere. I mentioned earlier there's three main parts, something called the chromosphere, the corona, and the photosphere. So there's the outer layer, what we see. There's a thin color layer. The color layer, think of the color, think of what means color. And then there's the extension layer. The extension is the glow, we'll say, of the sun. So what we see, the color we see, and the extension layer might help you understand how to identify these. Think about chromosphere versus photosphere. A photo is something you see, might give you a little bit of a hint here. So, a couple other parts that we're going to have to talk about and identify are things called sunspots. Obviously, we recognize what the sunspots would be. The prominence, we're going to identify what the prominence is, and obviously solar wind is a very important part of the sun and how it reacts to Earth. So, in those regards, that's what we're going to be talking about. Obviously, how big is the sun, but ultimately the different parts of the sun, and you're going to walk away with understanding what fusion is. So that's today's lesson, Introduction to the Sun. All the best.